Hi, this is John Linneball, and this is How to Solve SAT Word Problems, official SAT practice test number 1. And I'm John Linneball with John Linneball Tutoring. Here's my website, here's my mailing address, here's my office phone number, and there's my email. All right, let's get started. Many SAT math problems are word problems. Word problems, or story problems, aren't just equations to solve. They involve arithmetic, geometry, trigonometry, etc., set into normal English words describing a situation or telling a story, if you like. It is your job to set up the equations and/or draw diagrams based on the words in the problem. The hardest part of an SAT word problem is almost always just setting up the problem. The math is usually pretty straightforward. You may also need to know a shortcut or a piece of mathematical knowledge that makes solving the problem much easier. So, we're going to use official SAT practice tests, in this case the first one that they published, number 1. And the College Board's official practice test can be found at the link in the description below, in the description, as I said. Okay, it's going to be below this video, so you'll see that. Anyway, they're free and they came from the actual makers of the SAT, so how can we go wrong with those? You can't. So, meta questions. I call these meta questions because they go above the normal word problems and require you to understand how you set up equations from word problems, or how to work backwards from an equation to understand how the equation was constructed. You could also call the latter kind, that is the work backwards from an equation to understand how the equation was constructed, reverse engineering questions if you like. Or call them whatever you want, doesn't make a difference to me really. So let's go to question number 3 in section 3, that's the no calculator section of official test number 1. On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? So here's one where literally all the SAT is testing is your ability to set up the equation. If we know Armand sent M text messages per hour for 5 hours, he sent a total of 5 times M, or 5M messages over that 5-hour period, since distance or work is equal to the rate times the time. So here the messages would best be described as work. Since the rate is M messages per hour and the time is 5 hours, we just multiply it to get 5M. By the same logic, the number of messages Tyrone sent is 4P, since he sent P text per hour for 4 hours, so you just multiply 4 times P. This question asks for the total number of messages, total, sum, cumulative, etc. Those all mean add. So the answer is 4M plus 5P, which is D. Kathy is a repair technician. This is problem number 4, so it's the one right after it. After number 3, the one we just did. Okay, so Kathy is a repair technician for a phone company. Here's some janky old phones that look like they're from about the year 2000. Anyway, Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. So what is the meaning of the value 108 in this equation? Kathy will complete the repairs within 108 days. Kathy starts each week with 108 phones to fix. Kathy repairs phones at a rate of 108 per hour, or Kathy repairs phones at a rate of 108 per day. So this is also a question where all the SAT tests is your ability to set up the equation. You don't even need to set up the whole equation as long as you can figure out the one part they're talking about. So here they just want to know what the 108 represents. Well, the problem states the number left at the end of each day is 100 minus 23D, so 108 has to be the number of phones she's given at the beginning of the week, and 23 is the number of phones Kathy can fix in one day. Should be number of phones, not phone. Oh well, sue me if you don't like it. Anyway, we can see obviously she does 23 a day, and that is, because it's 23 times the number of days, and it's subtracted from 108. So it has to be B, that Kathy starts each week with 108 phones to fix. Question 6, section 3, official test number 1. So here we have question number 6. A pediatrician uses the model above, h equals 3a plus 28.6, to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So this question is again where really the SAT is just testing you on your ability to set up the equation. Again, you don't even need to set up the whole equation as long as you can figure out the one part they're asking about. So here they want to know what the 3 represents. Well, the problem tells you that A is the age of the boy in years, and 3 is the coefficient, that is the number by which you're multiplying A. So 3 is the coefficient of A, and the equation is equal to H, the height of the boy in inches. So you should be able to figure out that, okay, if H is in inches, 3A must also be in inches, and probably this is 28.6 inches. So you should be able to figure out that 3 is the number of inches the model assumes the boy will grow in a year. So A is the right answer. The 28.6 is the boy's height at 2 years old, but we don't necessarily need to use that. It is helpful to know that in general. I mean, the more completely you understand the formula, the less likely you are to make a careless mistake, like dividing 28.6 by 2 or 3 to get 14.3 or 9.5. Question 11, Section 3, Official Test Number 1. So, in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? All right, so we see then we're going to have to set B and C equal to each other, and then we'll just be able to solve the combined equation because it'll just become one equation. So this is a straightforward simultaneous equations problem, since they want to know what the price of beef is equal to when it's equal to the price of chicken, and where B is the price of beef and C is the price of chicken. All we have to do is set B equal to C. Since they're equal, we can just eliminate B and C and combine the two equations into one equation. So $2.35 plus 0.25, $2.35 plus 25 cents times X equals $1.75 plus 40 cents times X. And so then when we combine like terms, we end up with 0.60 equals 0.15x. When we combine like terms, so then we're going to divide 0.6 divided by 0.15, which is equal to 4. So the price of beef was $2.35 plus 25 cents times 4. We know that's going to be $1, 25 cents times 4, so that's just going to be $2.35 plus $1 is $3.35. We can check it by using the formula for chicken. Well, $1.75 plus 0.4 times 4 is going to be $1.75 plus $1.60, which is $3.35. I hope you're not upset that I didn't use the dollar sign here. Anyway, the answer is D, $3.35. Which a long time ago was the minimum wage, but that's not important right now. Question 17, Section 3, Official Test Number 1. So we're going to read the problem here. A summer camp counselor wants to find a length X, here's X, in feet across a lake as represented in the sketch above. So the lengths represented by AB, there's AB, EB, there's EB, BD, there's BD, and CD were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet respectively. So respectively means in that order. So we go AB, okay, then the first one's 1,800. Oh, okay, so AB is 1,800. So you can see I marked that there. And then EB, all right, we have EB. They say that that's 1,400 because that's the second one. So respectively, that means they're in the same order. So EB is 1,400, then 700. Okay, that's the third one. Oh, that's BD. And then, of course, 800 is the last one, which is CD. Okay, so we can see that EB and BD are similar because they're on both sides connecting vertical angles. We have EB here, BD there. And also they're on the same side as angle E and angle D, and we can see from this little line that they're equal to each other. So, and of course these angles here are vertical angles, so they have to be the same. So these have to be proportionate. We can see that these triangles are similar triangles because they have two identical angles, of identical measure. So that means the third one, by definition, also has to be the same. So if the angles are the same, that means they're similar triangles, which means all the sides are proportionate. So since EB is twice BD, and those have to be proportionate for the reasons I just explained, then, okay, That's 700, that's 1400. That means if this is 1800 AB, this one that's proportionate BC has to be half. So it's going to be 900, because this is the bigger triangle and this is a smaller triangle, and we know the ratio of similitude or similarity is 2. So since that's 900 and since we know this is 800 here, then AE, which is what we're trying to figure out because we know that's x feet, is going to be 1600, and the answer is 1600, and you can grid that in. All right, let's go to the next question. Question 19, section 3, official test number 1. So here, question 19, in a right triangle, one angle measures x degrees, where sine of x is equal to 4 over 5. What is cosine of 90 degrees minus x? Well, okay, so let's draw a right triangle. So we draw the little box here so we know it's a right triangle. And so we'll make one of these x. Okay, obviously it's not the right angle, so it's got to be one of the other ones. And we know these two have to add up to 90. Why? Because 90 plus 90 equals 180, and since this is 90, these two have to add up to 180 minus 90, which is 90, so x plus y is 90. All right, so we know that the sine of x is the opposite over the hypotenuse. So here's the opposite, because it's opposite the angle. Hypotenuse is always the side that's the longest one, and it's opposite the right angle. So we can just say this is 4 and this is 5, and then we have the proper ratio of 4 to 5 for the sine. Now, y, they want to know what cosine of 90 degrees minus x. Well, hey, we're in luck. Y is 90 degrees minus x. So the cosine is going to be the adjacent. Hey, that's 4. And over the hypotenuse, which is 5, hey, that's 4 over 5. So we can see, oh, I get it. Cosine of 90 degrees minus x is equal to sine of x. So if you know that trick, then you just grid in 4/5 right away. If you don't, you just quickly figure it out by drawing this little diagram, and you say, gosh, they got me. They fooled me into having to do more work than I had to. Okay, the worst possible way to do it, at least the worst one that I can think of that would actually give you the right answer eventually, would be, okay, we go use our calculator. And we're going to take 4 over 5, 0.8. Then we go take the inverse sine of that. We get 53.13 degrees roughly. And then we take the cosine of that. And voila, you get 0.6. So that's going to be, you know, oh, wait a minute, I did it wrong. See, that's one reason you don't want to do it, is because you go, there's too many moving parts. Okay, so you go 4 over 5. Then we take the inverse sine, 53.3. Okay, and then you have to subtract it from 90. That's where I made a mistake here. So, boom. We get, oh, that's 90 divided by 15. That's, geez, okay. So we're going to go 53.3. No, it's, all right, let's start it over again. 0.8. We're going to take the inverse sine, 53.13. Okay, so that is this. That's x. So we're going to subtract that from 90. That's going to be 36.869 and blah, 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 blah. So roughly 36.87. Then we take the cosine of that. Boom, we get 0.8. Now you see how many mistakes I made, how many mistakes I can make doing it that way. It's the long way. It's likely to be the wrong way. There's lots of places you can make a mistake on that one. And since this is a grid-in problem, you could miss it. So please make sure you just draw the diagram, recognize the things right away that, you know, oh, wait a minute, the cosine of y is the same as the sine of x, and it becomes much easier. You grid in 4.5. You can grid it in as 0.8 if you insist. All right, so there's a method to my madness here. All right, official test number 1, section 4. Hey, that's the calculator section. Question 1. So John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? All right, so strictly increasing means exactly what you think it does. It means doing nothing but increasing, and strictly decreasing means doing nothing but decreasing. So it means it's got to be something like this, where it goes up and then boom, goes right down. So there's no flat parts. So A, between 0 and 30 minutes, well, 0 and 30, no, there's a big flat part. That's neither strictly increasing nor strictly decreasing, so that can't be it. 40 and 60, okay, strictly increasing from 40 to 50. Then 50 to 60 drops, there's no flat part, that looks right. So 50 and 65, the problem is, well, let's see, 50, it goes down, and 65, it goes up. That's great, but it's strictly decreasing than strictly increasing, so it's just got it backwards. So that means it's wrong. So 70 and 90, well, 70, it's flat here, then it's increasing, then it's flat to 90, so no, and it doesn't really decrease anywhere, it just increases or is flat. So it's got to be B. All right. Official test number 1, section 4, question 4. If 16 plus 4x is 10 more than 14, what's the value of 8x? Well, this is just setting up the problem 16 plus x equals 10 more than 14. Okay, 10 more than 14 means 10 plus 14. So 16 plus 4x is equal to 10 plus 14, or that means 24 is equal to 16 plus 4x. I just flipped them around and added these two together. So, okay, so then we just subtract 16 from each side, so we get 8 equals 4x. So to find to find 8x, we have to just multiply 4x times 2, so we can just multiply both sides by 2, and we quickly see that 8x is equal to 16, which is answer C. Official test number 1, section 4, question 6. All right, we have 1 decagram is equal to 10 grams, and 1,000 milligrams is equal to 1 gram. So, a hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? Well, the first thing what we could do is just convert milligrams to decagrams. So we know there's 1,000, or convert, milligrams to grams to decagrams. Yeah, so anyway. Since there are 1,000 milligrams in a gram and 10 grams in a decagram, all we have to do is multiply 1,000 milligrams per gram times 10 grams per decagram, and we end up with 10,000 milligrams per decagram. Notice this is just like physics or chemistry class. You want to make sure the units cancel out. So the grams cancel out, we end up with 1,000 milligrams per decagram. That works fine. Do we see that as an answer choice? Oh, we don't. Oh, it says a 2 decagram container. So we just multiply by 2, since it's in a 2 decagram container, to get D, 20,000. And yes, the first time I did this problem, I didn't notice that it said 2 decagrams, so I was wondering, why are all these a factor of 2? They're all... So, anyway. Note the other answers are all off by orders of magnitude, so even if you didn't multiply by 2, you should be able to guess the right answer, which of course I was able to do and quickly realized, oh, they said 2 decagram. So don't be afraid to reread problems. If something looks wrong, obviously if you don't see the answer you got as an answer choice, you better go back and check. Section 4, official test number 1, question 7. All right, so we have rooftop solar panel installations in 5 cities. So the number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? Well, we see these numbers. The vertical axis is the one that goes up and down. It's the y-axis. So we have 0 through 9. Not 1 through 9, 0 through 9. All right, so if we add these together really quickly, we get 9 plus 5 plus 6 plus 4 plus 3, 3.5. So 9 plus 5 plus 6 plus 4 plus 3.5. That adds up to 27.5. We can even use a calculator, which I do recommend. If you can use a calculator, please do use a calculator. So that's 9 plus 5. That's 14. Plus 6 is 20. Plus 4 is 24, plus 3.5 is 27.5. So, since the problem tells us the total number of installations is 27,500, the only label that would make sense is C, the number of installations in 1,000, since you'd multiply 27.5 times 1,000 to get 27,500. Official test number 1, section 4, questions 9 and 10. All right. So questions 9 and 10 refer to the following information. A is equal to 1052 plus 1.08 t. The speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave in feet per second, and T, the air temperature in degrees Fahrenheit. So, which of the following expresses the air temperature in terms of the speed of a sound wave? All right. So, first they tell you the temperature is T, so we want to solve for T. Just like Mr. T. I pity the fool, don't solve for T. I know, I sound just like him, don't I? No, okay. Anyway, so we're going to solve for T. So first of all, we're going to subtract 1052, so we get A minus 1052 is equal to 1.08 T. Then A minus 1052 over 1.08 is equal to T. And then we're done. That's choice A. So it's A minus 1052 over 1.08. Now, here's question number 10. At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So since A is equal to 1052 plus 1.08 T from the original equation, remember, right here, see, that's where we got that. So all we need is a value of T that makes 1.08 T approximately negative 52, so we need 1,000 minus 52. So 1.08 T, so we just have to divide negative 52 by 1.08. And all we do is go negative 52, so we'll just subtract 52 from 0, and then we will divide by 1.08. So that's 48.148, 148, 148, so the 148 just keeps repeating, so that's negative 48 degrees Fahrenheit, and those of you who are chemistry, physics, etc. students might recall that degrees Fahrenheit and degrees Celsius are the same at negative 40 degrees Fahrenheit or negative 40 degrees Celsius because they're the same. That doesn't really have much to do with this, but it's just a little bit of trivia that popped into my head. So anyway, the answer is B, negative 48 degrees Fahrenheit, which is very cold. Okay. Official test 1, section 4, question 12. We have a chart here that shows the number of apples and the number of seeds in each of 12 apples. Okay, so we have 2 apples. This is the number of apples that have 3 seeds. And, okay, 5 apples that have 4 seeds. Let's read the problem. Based on the histogram above, of the following, which is the closest to the average or arithmetic mean number of seeds per apple? In case you haven't watched a video where I've gone over an SAT problem before, whenever they put arithmetic mean in parentheses after average, it means the same thing, no pun intended. Haha, know what I mean? Anyway, basically, average and arithmetic mean have the same meaning. So the reason they put it there is just so that way no one can complain and say, my math teacher only used average, or my math teacher used arithmetic mean, so I couldn't understand the problem. It's not fair. They give you both. Anyway, number of seeds per apple. So this is what's called a weighted average. The first bar says 2 apples, vertical or y-axis, so this is 2, have 3 seeds per apple, which is on the horizontal or x-axis, so that's 6 seeds for 2 apples. Second bar, okay, there are 4 apples with 5 seeds, so 4 times 5 is 20. There's 1 apple that had 6 seeds, so that's 6 seeds. Fourth bar is 2 apples with 7 seeds, that's 14. And then there were 3 apples with 9 seeds, which is 27. So it's 6 plus 20 plus 6 plus 14 plus 27 seeds over 12 apples, which is 73 over 12, approximately 6 seeds per apple, so that's going to be choice C. Official test number 1, section 4, question 13. Okay, so here we have another chart. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for the approximately 19% of all the survey respondents? All right, so one nice thing is they sum it up for you, so whether you go by the total in each course or the total male and total female students, either way you get a total of 310 students. So we need to know 19% of the survey respondents. So 19% is obviously pretty close to 20%, And it's really easy to figure out 10%, and 20% is 2 times 10%. So all we have to do is say, okay, 10% of 310 is just 1/10. You just move the decimal point, so it's 31.0. And then 2 times 10% is then 2 times 31, which is 62. So since B, the females taking Algebra 2, is 62, you might be tempted to just say, oh, that's it. That's easy. Not so fast. Use your calculator. Let's look for ones that are close. You have males taking geometry. That's 59. So we know that 57 over 310 would be a little bit more than 19% for the males taking Algebra 2. So how do we know which is which? Well, you're allowed to use your calculator, so go ahead and do it. So go 59 over 310. Okay, that's 19.1903. We can even multiply it by 100 to get a percentage. So that's 19.03. That's probably right. Doesn't really take much more time to just check it and be sure to make sure the 57 isn't it. So that's 18.38%. We can multiply it by 100 in case you're concerned. 18.387, so it's about 8, that's more 18%. So that's one way to do it, is just kind of brute force it once you realize that these have to be around, 59, 57 have to be close. And you get that the answer is 59, which is choice C, because you have to go 59 and say, okay, it's male and it's taking geometry, so that's going to be the right answer. Another way to do it, which is kind of neat, is you could say, okay, 1% of 310, times, well, okay, we just go 0.01 for 1% is 3.1, so 1% is approximately 3, and then you just subtract that from 62. So I just made it negative, and I'm going to add it to 62. Boom, that's 58.9 or 59. So either way is all right. I guess another way you could have even done it is you could just go 310 times, you know what? Let's go back to the regular calculator. We'll go 310 times 19%, which is 0.19, 58.9. So again, it'd be 59. So there are a number of ways you can do that, especially if you're using a better calculator than the Windows calculator that I'm using right here. Okay, well, it's actually pretty good, but you have to switch back between standard and scientific, and it's just a little bit annoying. Okay. So, official test number 1, section 4, question 14. The lengths of fish in inches. So, the table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. So, the very biggest one, 24, that's an outlier. It's an unusual value, and in fact, it's an error. So, of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? The mean, median, range, or they will all change by the same amount. Well, the mean, the weighted average, we can literally just go, okay, there's one value that's 8, that's 8. There are 3 9s, so we can have 3 times 9. We have 2 10s, so that's 2 times 10. Then we have 2 times 11. We have 4 times 12. We have 3 times 13, 2 times 14, 2 times 15, a 16, and a 24. So this is the weighted average when we don't take out the outlier. Okay, so that's going to be very quickly, okay, we're going to do 8 plus, okay, we know 3 times 9 is 27, right? Plus 2 times 10 is 20, plus 22, plus 4 times 12 is 48, plus 3 times 13 is 39, plus 28, plus 30, plus 16, plus 24. And so that's 262. We're going to divide that by 21, so we get 12.476, blah, 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 blah. Okay, so then what we'll do is we will subtract that. All right, what we're going to do, we'll just add that to the memory. Then we're going to clear it out, and then we're going to just take, okay, we can do the same thing. We do 262. Okay, minus 24. So we're taking out the outlier, and then we're going to divide that by 20, because now we only have 20 values, not 21. 11.9, Let's make that a negative. And then we're going to add that. Oops. All right. Let's do it 11.9. And I messed that up with the memory thing, but okay. So we'll just go 262 over 21. Boom, 12.476. And then we're going to go minus 11.9. And we get 0.576 of roughly 0.6. So that's the difference in the weighted average. That's going to be the change. Okay, so the median won't change at all, and I'll explain why the median won't change at all. It's because, okay, the median, we have 21 values. They tell you there's 21 values, but also you could just count it. You go 7, 14, 21. So that means all you have to do, since there's an odd number, is you know that there's going to be 10 before it. Number 11 is the median, and then there's going to be 10 afterwards. That's what makes number 11 the median. So here's 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is 12. That's wonderful. If we take this out, then there's going to be 20 values, so we have to basically average the 10th and 11th value because there's an even number. When you have an even number of values, you have to take the two middle numbers and average them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so we go 7, 8, 9, 10, and 11. The average of these two, 10 and 11, is still 12, because it's just 12 plus 12 divided by 2. Even if I missed by 1, it wouldn't matter. These are all 12. It's going to be in this range. The average of the two has to be 12. So B won't change at all. C, the range is the difference between the largest and the smallest value. When we have 24 in here, then it's 24 minus 8, that's 16. When you take it out, 16 minus 8 is the range, so that goes from 24 minus 8 is 16 to 16 minus 8, which is 8. So that's going to change by 8. All right, so D, they will all change by the same amount? No, we know they won't because we've tested all three and they all change by different amounts. So the largest one has to be the range. On the real test, you could probably just guess that A is going to change the least, but it doesn't take very long to calculate it. So I would suggest that you do just give your calculator a little workout on the test. All right, official test number 1, section 4, question 15. So we have questions 15 and 16 refer to the following information. What's the total cost of renting a boat by the hour? So we have a chart here where C is the total cost in dollars. That's the y-axis. The x-axis is the number of hours that it's rented. So what does the c-intercept represent in the graph? So this is the y-intercept. It's the y-intercept is the c-intercept. So we can see that where the time is 0, or x is equal to 0, or h is equal to 0, whatever you want to call it, if you haven't rented it for any hours, you're still paying $5. So this is going to be very similar to the flag drop in a taxi. Even if you got into a cab and the meter started running, even if you got out without going anywhere, technically you'd be stuck paying the initial charge. So this is similar. You know, as soon as you sign that rental paperwork or whatever for the boat rental, you're paying that even if you realize you have to go home and you're not going to have any time to use the boat. So, you know, might also be if you had to leave after 10 minutes in the boat, or after you rode 10 feet in the cab or something like that. They say, you know, we can let the 10 minutes or the 10 feet go, but you got to pay us the initial charge. So the answer is A, the initial cost of renting the boat. B is wrong because the total number of boats rented, well, it says a boat, so it's just one boat rented. C is wrong because the total number of hours the boat is rented. No, that would be the value of H along the H or X axis, labeled time and hours. D, the increase in cost to rent the boat for each additional hour. Well, we can see that C is 5 at the C-intercept, or I'm sorry, you know, yeah, C is 5. So, but if you go every hour, after 1 hour it's 8, after 2 hours it's 11, After 3 hours, it's 14. So that's going to be 5 plus 3h because it increases by $3 every hour. So that's not the increase in cost to rent the boat for each additional hour. All right, so question number 16, which of the following represents the relationship between H and C? I probably just explained it all to you. I explained it all to you. Anyway, for the reasons we've discussed, the flag drop or initial cost is $5, and every hour of rental time adds $3. So the only possible right answer is C equals 3H plus 5. It's not C equals 5H because... no, I mean, otherwise it would just be a flat rate of $5 per hour, and we see that you pay $5 at the beginning and then $3 per actual hour that you used it. So, checking points on the graph can also help. Well, as we saw before, after 1 hour it's $8, after 2 hours it's $11. So, that doesn't work. B gives us 5 3/4 after 1 hour. So that doesn't work. That'd be $5.75. C gives us $8, which is the right answer. And D gives us C, H is equal to 3C, so then C would have to be 1/3 H. So that would be that you're renting it for 33.33333, 33 1/3 cents per hour, which would be a really nice price, but I don't think they're going to really rent you a boat for that much, and that's certainly not what the graph shows. So plugging in numbers, or back solving, which is what we just did, is an effective way to solve an SAT problem quickly when it's a math problem, and it's also the first tactic I ever learned for multiple choice math problems. This will also work for vocabulary questions. Just plug each meaning into the sentence to see which one makes sense to you. Anyway, official test 1, section 4, question 19. A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks, so it's the total of salads and drinks, it's not just 209 salads and then some drinks that they don't specify, in one day was $836.50. How many salads were sold that day? So this is an SAT classic. We have two variables and two equations. Let's have S equal to the number of salads sold that day, and let D equal the number of drinks. We know S plus D is equal to 209. We also know that 650 times S plus 2D is $836.50. We want to find the number of salads, so let's eliminate the number of drinks by... it's not by seeing D, well, actually, it is by seeing, sorry, I was going to say by setting D, but by seeing that D is equal to 209 minus S, and then substituting that into the other equation. That is the $836.50. So we end up with 650 times S plus 2 times 209 minus S equals $836.50. Use your calculator. So let's use our calculator. Okay. So we know that 650s minus 2s, so we're going to get 450s, and then, so 650, okay, minus 2, so that's 4.5, and then we know that 2 times 209 is 418. So we know that 650 plus 2 times 209 minus S is just going to be 418 plus 450S is equal to 836.50. So, which is what we have here after you get the 650S plus 418 minus $2S is 36.50, so 450 times S plus 418 is equal to 836.50. So let's subtract the 418 from 836.50, which is $418.50 is equal to 450 times S. So now we're just going to divide by 450. And that's 93. So we get S is equal to 93, which is choice B. Easy peasy. All right. Number 20. Alma bought a laptop computer at a store that gave 20% discount off its original price. That gave a 20% discount off its original price. The total amount she paid to the cashier was $P, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Well, all right, let's set up the problem. Let OP equal the original price. You know, the OG would pay the OP. All right, JK, just kidding. Anyway, P, the price Alma bought, would be found by taking 20% off the OP and adding an 8% sales tax. So P is equal to OP times 0.8 times 1.08. But what we're supposed to do is solve for OP. No problem. So we just divide P by everything on the other side of the equation but OP. So OP is by itself. So we just take, we know that P is equal to OP times 0.8 times 1.08. We just divide by 0.8 and then divide by 1.08. OP is equal to P over 0.8 times 1.08, which is choice D. We can also solve this by just making the problem, we could just make the original price $100 because it's a percentage problem. When you're doing a percentage problem, it's always the best just to make it 100 or a multiple of 100. So we get 100 times 80%, which is 0.8. Boom, it's $80. And now we're going to add 8%, so we can go plus 8%, which is 6.4. Boom, it's 86.4. So now what we can do is just plug this in and see which one of these equations actually gives us $100 when we plug it in. 86.4 times 0.88. No, that's not it. So we can divide by 0.88 to get back to where we started, 86.4. Okay, so then P over 0.88, well, all right, over 0.88. 98 that's pretty close, but not close enough. And then, okay, so we're going to multiply by 1.08. Oops. All right, we're going to go 86.4 times 0.8 times 1.08. Ooh, that's not even close. That's 74.65. Okay, so that's not it. So then we're going to go 86.4, the price, and then we are going to divide by 0.8, and then we're going to divide by 1.08, which gives us 100. So we know it's choice D. So plugging in numbers is another way to do this. When you need to figure out something involving variables and equations, just pick numbers that are easy to work with, where you know what number the correct equation should give you. If you end up with two of these choices giving you the same number, then either plug in different numbers, or hopefully at that point you've already figured out how the equation works and you know which answer is the right one. All right, so question 21. This is official test 1, section 4. This is going to be the dreams recalled during 1 week. So the data in the table above, this table here, were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what's the probability that the person belonged to Group Y? Well, the probability of anything is the number of desired outcomes, or the number of outcomes that you're looking for, and which is going to be anything, the number of desired outcomes over the number of possible outcomes. So that would be anything that you're looking for over anything plus anything else. I know it looks like we're multiplying these two together, but we're not. So it's just going to be the number of desired outcomes over the number of possible outcomes. So first of all, notice that they chose at random from those who recalled at least one dream. So we're not even going to look at the people who didn't recall any dreams. So that's not out of 200, which would be the total. It has to be the total who recalled at least one dream is 39 plus 125. So it's 39 here plus 125. Again, as I said, make sure you use your calculator. So that's going to be 39 plus 125. That's 164. And the total in Group Y, who recalled at least one dream, is 11 plus 68. So that's, we can see 11 plus 68. So that's going to be 68 plus 11, which is 79, and then we divide that by 164. And so that's 0.4817, da, 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 da. But if I looked at the answer choices, I would realize, oh, I could just go 79 over 164, and that's answer choice C. So, but if they needed a decimal, you could do this, and you say, okay, so it's approximately 0.48. All right. Anyway, that's choice C. All right, questions 22 and 23 refer to the following information. And so here are the annual budgets for different programs in Kansas, 2007 to 2010. All right, so let's look at question 22. Which of the following best approximates the average rate of change in the annual budget for the agriculture/natural resources in Kansas from 2008 to 2010? Well, this involves the, mouse got out of control here. All right. Over 2 years, that is from 2008 to 2009 and 2009 to 2010. So we just want to subtract the 2008 value from the 2010 value to get the total change and divide by 2 to average the change. So that's 2010 minus 2008 over 2. Well, we see the 2010 is 488,106, and the 2008 is 358,708. And yes, that's actually this times 1,000. These are all in thousands of dollars. Do we care? No, because the thousands will cancel out in the equation. So we just go 488,106 minus 358,708 over 2, which is 64,699. If you don't believe me, I don't blame you, but here, let's do it. 488,106 minus 358,708. Boom, that's 129,398 divided by 2, 64,699. So basically 65,000 per year. That's the closest answer. They says best approximate, so that would be the closest answer is what they're looking for. Official test number 1, section 4, question 23. Of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the Human Resources Program's ratio of its 2007 budget to its 2010 budget? So we have agriculture/natural resources, education, highways and transportation, or public safety. All right, so HR's ratio of its 2010 to 2007. And again, we can go look. Okay, so that's going to be 5,921, 5,921,379 over, and let's see, did it say 2007? Yeah, so that's going to be, okay, so, actually it should be the ratio of 2007 to 2010, so I made a mistake here, but I got the equation right. Okay, so it's 4,051,050 in 2007, and we can check that. Yep, right there. Over 5,921,379. So that's going to be approximately 0.684. And we can go 4,051,050. Oops. Okay, 4,051,050 divided by 5,900. Okay, 5,921,379, which is, all right, roughly 0.684. So, all right. Education, same values, 2,164,607 over 3, okay, 008,006. So that's 71.9, so roughly 0.720. Highways and transportation, it's going to be 1,468,482 over 1,773,893, which is roughly 82.7, so 82.8%, 0.828. Then public safety is going to be 263,463 over 464,233. So that's about 0.568. Let's see, 263, 463. Looks like I was off by an order of magnitude. So let's do that again. 464 to 33. Well, it should be, yeah. It's about 56.75, so roughly 0.568. So we can see from these values that we got from here, basically just, you know, you can see public safety, take this, divide it by that. Highways and transportation, you take this, divide it by that, blah, blah, blah. So B is closest to the HR's human resources budget ratio. So their difference is going to be roughly 0.720 minus 0.684, which is 0.036. So the A, C, and D, we can see they're all bigger differences. You can go 0.766 minus 0.684. That's 0.82. And then the other one is it's going to be 0.828 minus 0.684, which is 0.144. And then you're going to have 0.684 minus 0.568. Oops. 0.684 minus 0.568. So it's going to be 0.116. So we can see all those other differences are larger, therefore cannot be the closest. All right. Official test 1, section 4, question 25. We have h equals negative 4.9t squared plus 25t. The equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. Well, we can see this guy's juggling a bunch of balls and launching them all directly up into the air. So, after approximately how many seconds will the ball hit the ground? Well, first thing we can do is set h equal to 0 because we want to know when the ball is going to hit the ground. The ball hits the ground when its height is 0. So 0 is equal to negative 4.9t squared plus 25t. So 4.9t squared, we're just going to add 4.9t squared to each side. 4.9t squared is equal to 25t. Divide both sides by 4.9t, and t is approximately equal to 25 over 4.9, because we're just going to divide through by 4.9t, so the t's cancel out, or approximately 5.1 seconds. 5.0 is the closest answer, and yes, 5.1 is the answer the SAT people get in the answer explanation, but they tell you to choose 5.0 because it is the closest one, so that's approximately. You can guess this since 25 over 4.9 is pretty close to 25 over 5, which is 5. And if you don't believe me, here, I can actually show you. It's going to be 25 over 4.9 is roughly 5.1 seconds. Okay, so it's answer choice D. Official test 1, section 4, question 26. Katerina is a botanist studying the production of pears by two types of pear trees. She noticed that type A trees produce 20% more pears than type B trees did. Based on Katerina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce? Well, percent change is always going to be the new value minus the old value over the old value times 100%. So remember, the old value is always the one that goes on the bottom. So whatever you're subtracting from the new value, that goes on the bottom. And that includes if the old value is greater than the new value. You can have a negative percent change. So, that would be a decrease. So in this case, it's type A minus type B over type B times 100% equals 20%. So the first thing that we're going to do is plug in the 144. So it's 144 minus the number produced by type B over the number produced by type B times 100% equals 20%. So the next thing we do is divide by 100%. So we get 144 minus type B over type B is equal to 1/5. So 144 minus type B is equal to 1/5 times type B, because we're multiplying through by type B to get it out of the denominator. So then we just add type B to both sides. So we end up with 6/5 times the number produced by type B is equal to 144, and type B is equal to 5/6 times 144. 5/6 times 6 times 2 times 12. I just factored 144 here to 12 times 12, and then factored the 12 to 6 times 2. So boom, we end up with 5 times 12, or 5 times 2 times 12 rather, because these 6 cancel out. So you have 5 times 2 times 12 equals 120. Factoring can really help. Of course, you don't have to do it that way since it's on the calculator section. So you literally could just go 5 over 6, get that number, and then multiply that by 144, and that will also give you 120. But they could actually put this on the no calculator section, and then you would have to do it this way. Official test number 1, section 4, question 27. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. So we can see, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 regions, and it looks like they vary from 107 to 176. So, since there are 10 1 square meter sample plots, that's 10% of the field, because we know the field is 100 square meters because it's 10 by 10. So if we add each sample plot's number of earthworms, we get 1471. And again, you don't have to believe me, I can do it right here for you. So we're going to go 107 plus 147 plus 146 plus 135 plus 149 plus 141 plus 150 plus 154 plus 176 plus 166. We get 1471. And since that's 10%, we need to multiply it by 10 to get an estimate of 100% of the field, the whole field. So that's, oops, that's not what I need to do. I multiplied by 100 instead of 10, so I can just divide by 10 to fix it. Boom, 14,710, so that's roughly 15,000. Okay, we don't even have to add the exact numbers. If we just assume it's roughly 150, so that's 150 times 10 to get the number in the sample plots. And then we say, okay, that's only 10%, so we multiply by 10, we get 15,000. So we've seen why it's important to multiply correctly. Luckily, I understood 150,000 isn't realistic. And so then we say multiplying by 10 gives us roughly 15,000 either way. Because if you estimate it at 1471 from adding it, or if you just say it's roughly 1,500, you're going to end up with an estimate of 15,000 either way. And notice these are all, again, different by an order of magnitude, which is just a fancy way to say a multiple of 10. So there's no way that you're going to be off by an order of magnitude in an estimate unless you really messed something up. So with these answers spaced that far apart, you should have no trouble telling that it's answer choice C. All right, let's see if we can get this to go. Official test 1, section 4, question 31. Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on that information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? So we're going to let W equal the number of dozens of ears Wyatt can husk per hour. We see that 12 is less than or equal to W, which is less than or equal to 18. So we get 72 dozen divided by 12 dozen. Notice the dozens cancel out, and doing the dozens is a kind of it's kind of like capping or signifying or snapping, but that doesn't have anything to do with anything other than I just saw the dozens. Ha ha ha. Anyway, so those cancel out and we get 72 over 12 equals 6. So 72 dozen is going to be equal to 9 times 8. 72 dozen over 18 dozen, I should say, is going to be equal to 9 times 8 over 9 times 2 We can see that the 9's cancel out because this factoring is really easy. So boom, boom, we get 8 over 2, which is equal to 4. So any number between 4 and 6, because 72 over 12 is 6, and then 8 over 2 is 4, any number between 4 and 6 inclusive will work. Doesn't even have to be an integer. You could grid in 5.34 if you want, and they would accept that as an answer. That is in the official answer guide. Not the 5.34, but any number between 4 and 6 inclusive. So, all right. Official test number 1, section 4, question 32. The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. I'll try that again. If the combined weight of the empty delivery truck and its driver is If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? Well, we know the maximum weight is 6,000 pounds. The empty truck and driver weigh a total of 4,500 pounds, so the amount of cargo the truck can legally and safely carry is going to be 6,000 minus 4,500 pounds, which is 1,500 pounds. So we divide 1,500 pounds by 14 pounds per package. We see the pounds cancel out, and we get 1 over package, which is just equal to package. So that's equal to 107.14 packages. If you don't believe me at this point, all right, we can just go 1,500 over, I believe it's 14, right? Okay, so, yep, over 14. So that's 107.14. Obviously, we're not going to have any partial packages, so you just truncate it to 107. So 107 packages is the maximum possible value. Okay, so official test 1, section 4, question 33. So we see that the number of portable media players sold worldwide each year from 2006 to 2011. According to the line graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? So we see in 2006 it was roughly 50 million sold. 2011, just about exactly 160. So we see 100 million sold in they want 2008. My mistake. So, okay, 100 million sold in 2008 and 160 sold in 2011. Okay, make sure you get the values right or you will definitely not get the problem right. So, we see 100 million sold in 2008, 160 million sold in 2011. So, you can just take 100 million players over 160 million players. Notice that the million players cancel out. We get 100 over 160, which is the same as 10 over 16, and which is the same as 5 over 8, because 2 times 5 is 10, 2 times 8 is 16. And you can convert that, you can go that 5 over 8 is 0.625, and if you don't believe me that 10 over 16 is the same thing, we can do that. So you can use your calculator to figure out the decimal, or if you just know the decimal, you could put it in there. I don't see any reason to. 5/8 is perfectly capable of being gridded in. You don't need to do that. Why do extra work? But anyway, there's your answer. Okay, and I'm having a little trouble controlling this thing here. All right, as seen on TV. Ooh, so we've all seen these late night TV commercials, right? So, Tuesday and Wednesday are 2 days. Well, let's read the question. I'm sorry. The question is, a local television station sells time slots for programs, perhaps nifty infomercials like this, in 30-minute intervals. If the station operates 24 hours per day, every day of the week, so that's 24/7, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? Well, we know Tuesday and Wednesday are both days, so together they are 2 days. Since a day is 24 hours, there are 48 hours in Tuesday and Wednesday. They also tell you that the station broadcasts 24 hours per day, so you wouldn't even have to know that there were 24 hours in a day. I wish that daily or weekly, etc. Your credit card definitely likes to compound what you owe the credit card company daily. Anyway, but I digress. The 1 indicates that all the money is in the account because anything times itself is 1, and the 0.02 is the extra 2% that accrues every year. So that's where the 1.02 comes from. We can test this with the $100 initial deposit at 2% per year. So all we have to do is go 1 plus 100 plus 2% is 102. And then we can do it again. We're going to add another 2% to, so after 2 years, boom, you have 104.04 because 2% of 102 is 2.04. Okay, so now we can try this the other way. We'll go to the scientific and we'll go 1.02 and then we'll make that, we'll square that for 2 years. So that's 1.0404 times $100 is 104.04. So we got the same answer for both. We know it works. So it is 1.02, grid that in. So you can always just check it with a very basic calculation to make sure that you got it right. Let's go to the next question. Jessica's friend, Tyshawn, found an account that earns 2.5% interest compounded annually. Tyshawn made an initial deposit of $100 into this account at the same time Jessica made a deposit of $100 into her account. After 10 years, how much money will Tyshawn's initial deposit have earned than Jessica's initial deposit? You want to round your answer to the nearest cent and ignore the $sign when gridding your response, because there's no way to grid in a $sign. So Jessica's interest over 10 years, assuming no additional deposits and no withdrawals, is 100 times 1.02 to the 10th. So we're going to go 1.02, and just from our formula before, and then we're going to take that to the 10th power. So that's 1.218. So let's just multiply that by 100. So it's 121.89. So roughly 121.90. Okay, so it's 121.90. And let's clear that. And the other one is going to be 1.025. And then we're going to take that to the 10th. So that's 1.28. times 100, so that's $128 roughly, or 128.01, and then minus the 120, minus 121.90, so we get 6.1084. I didn't round Tyshawn's there, so that's going to be 6.11. Or we just, we can round them both before and just go 128.01 minus 121.90. You get $6.11. So that's the answer, grid in 6.11. All right. So did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I also don't have anywhere near 1,000 subscribers. So, for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or people, things, etc. that are off topic, spammers, disturbed people who want to post things that don't have anything to do with my video. If you want to contact me, you can contact me at 415-623-4251. Calls are fine, texts are fine. You can email me at john@johnlinabal.com. My mailing address is 1859 Powell Street, number 109, San Francisco, California, 94133. Thank you so much for watching. If you have a copyright issue, any other kind of issue with my video, hey, contact me. I'd love to discuss it with you. And further contact information, you can find me on Facebook, just facebook.com/Linabal Tutoring. And I do actually have here it is, facebook.com/Linabal Tutoring, and Instagram, www.instagram.com/john.linabal.tutoring, and phone, this is my home office number, 415-986-7355, and email john@johnlinabal.com, or you can reach me at www.johnlinabal.com or johnlinabaltutoring.com or testpreparation.locals.com. All right. Hope you have a good day. Bye.